All right, welcome to Integrated Math 2. We're going to be starting with some pre-algebra and Algebra 1 review before we kick it into geometry. So we're going to start with being able to solve multi-step equations. So what does it mean to solve an equation? It means to find a value of an unknown. Normally represented by variables like x, or y, or n, or k. These are all examples of unknowns. They're usually represented by letters. And so when we're solving an equation, what we're trying to do is find how much these equal in the equation. So how do we go about solving an equation? You're going to do something called opposite operations. Okay? You're going to make it to where you'll hear me say all the time, getting x or getting the variable by itself. And you'll use opposite operations to do so. So that means if you see addition happening, you're going to do the opposite to get rid of it, to get it by itself. That would be subtraction. And if you see subtraction happening, you're going to do the opposite, which would be addition. Sorry about that, guys. All right, and if you see multiplication happening, you're going to use division. And of course, if you see division, you're going to use multiplication. And I'm going to give you plenty of examples of doing opposite operations. Now, there's something else that's going to happen when you're solving equations. You're also going to have to remember to use your order of operations to simplify before you can start solving. That is known as PEMDAS, or please excuse my dear Aunt Sally. All right, so P stands for parentheses, or any kind of grouping measure. So you would look for things like this, or here's another one you could see, or this. These are all groupings. You will always look for those first. You also, next will be E, which is exponents. That's whenever you have something that's raised to a power, okay? This is an exponent. You will look for that next. M is for multiplication. I'm probably misspelling it. What's new? All right, D is for division. A is for addition. And S is for subtraction. But these do not have to go in that order. You can do multiplication and division in any order. You just have to remember to always go from left to right. Same thing when we're talking about addition or subtraction. You can do addition or subtraction, whichever one you want to do first. Just remember to always go from left to right. That is what is important. Okay? All right, so I'm a firm believer in the best way to be able to understand how to do these things is to actually do them. So this is how your problems will be set up on your Google form, and I will show you how your answer should look when you type it in. So our first example here wants us to solve for n. So we have a lot that's going to happen here. First, we need to simplify by using PEMDAS and other things that we know. So we have a set of parentheses here, and we can't do anything with what's inside our parentheses, but if you remember, anytime you have something set outside a set of parentheses, there is something we're going to use called the distributive property, which means whatever's on the outside is going to multiply by whatever's on the inside. Okay? So nothing's happening with our negative 7n. It's just going to come down. But this negative 6 is going to distribute to everything inside the parentheses because it's written right next to it. And the reason that it is multiplication is because if you remember, anytime something is written right next to something else, it means multiplication is occurring. Like if I was just to write this, that would mean A times B. Okay? So we have negative 6 times 1, which is negative 6. And we have negative 6 times 7n. And that's going to give us negative 42n. And then bring this down because nothing's happening to it yet. Now, still wanting to solve for n, now we need to do something called combining like terms. So remember, like terms are things that are going to have the same variable and same exponent. So I notice here that I have negative 7n and I have negative 42n. They're like terms because they both have an n and just one n. Like it's not n squared, it's not n cubed, or anything like that. So when we combine those, so we'd say negative 7 minus 42, that gives us negative 49n. Now, let's bring down what else we know. Well, we still have a negative 6 happening, and we still have our negative 251. Now, here's when we can start solving. This is where opposite operations will come into play. So you can't start using opposite operations until you have it set up to where you have just one variable, and that's where you're going to go from. So when we're solving for this variable, we're looking at what is happening on the side of the equation that involves our variable. And we want to work out n, which means whatever is farthest away from n is what we're going to start with. If you notice, negative 49 is right next to n, so we're not going to start with it. But this negative 6 is farther away, so we're going to do the opposite. So this is subtraction of 6. The opposite of a subtraction of 6 is an addition of 6. And see this equal sign? That tells us we have a wall. Whatever happens on one side of the wall has to happen on the other side. So I'm also going to add 6 over here. We do this because now this zeroes out. It goes away. So we're left with negative 49n equals, and then we have negative 251 plus 6, negative 245. All right, n is still not by itself yet because we have multiplication occurring here. So the opposite of multiplication is division. So you're going to divide by whatever number is being multiplied here. So since it's multiplying by negative 49, we're going to divide by negative 49. And remember, whatever happens on one side has to also happen on the other. So we're also going to divide this side by a negative 49. And that gives us a final answer of n equals 5. Now, all you have to do if this was a question on your homework is you would type in 5. And that would be your final answer. Okay? We're going to do plenty of other examples to help you out. Okay? So here we go. Example 2. Solve for p. So again, let's look and see what we have going on. So we have a set of parentheses. We can't do anything inside our parentheses, but we also have a number outside of our parentheses. So remember, when that happened in example 1, we distributed. Well, the same thing is going to happen here. So we're going to distribute this 5 like so. So here we go. The negative 240 is going to just come down. All right, so we have 5 times 7p. That gives us 35p. Then we have 5 times positive 8. That gives us 40. Now remember, I told you once you get rid of your parentheses and once you have one single variable to solve for, that's when you can start doing opposite operations. So I'm looking at my wall. Here's the side that contains our variable. What is farthest away? Is this 35 farthest away or this positive 40? Well, 35 is right next to p, so it's not. But this 40 is far away. So the opposite of a positive 40 is a subtraction of 40. Whatever you do on one side, you must do on the other. That gives us now a total of negative 280 equals 35p. Okay, now let's continue solving for p because right now it has 35 right next to it. And if it's right next to it without like an addition or subtraction in between it, that means multiplication is occurring. So the opposite of multiplication is division. We're going to divide by whatever's right next to our variable, which is 35. And whatever you do on one side, you must do to the other. So we have negative 280 divided by 35. And that gives us that p equals negative 8. And of course, if this was a question on your homework, your final answer that you would just type in is negative 8. No spacing necessary. Okay, if you put a space in there, it's going to count it as wrong. It's very finicky, so just put -8. All right, let's keep going. I wanted to make sure you got plenty of examples. All right, example 3, we're going to solve for p again. All right, no parentheses are here, so we don't have to use distributive property. But if you notice, we have 2 variables. Are they like terms? Why, yes, they are. We know they are because they're both just single p's. So we can actually combine those, and it will make it a lot easier for us to solve this problem. So we have -3p plus 8p. That leaves us with 5p equals, and then bring down what we didn't have to change, our 15. Now let's solve for p. This one's the easiest one I think we're going to do. So p only has one thing happening to it. It has a multiplication of 5. The opposite of multiplication is division. Whatever we do to one side, we must do to the other. That leaves us with p equals 3. If this was a question on your homework, all you would type in is 3. Okay, still going. All right, example 4, solve for r. So we have -5r minus 2 minus 7 equals -24. No parentheses again, but we do have some like terms. This time, it's these right here that don't have any variables at all. They're still like terms that we can combine. So we're going to bring down our -5r, and we have -2 minus 7, that gives us -9 equals, and then bring down our -24. Now we can solve for r by using opposite operations. So here's our wall. We're going to see what is farthest away from r on its side of the wall. Okay, not -5, it's right next to it. But -9 is pretty far away. The opposite of subtraction of 9 is an addition of 9. Whatever you do to one side, remember, you must do to the other. So -24 plus 9. So we're left with -5r equals -15. All right, just like before, what we've done already 3 times. Whenever a number is written right next to the variable, that is multiplication. And we can get rid of that using division. And we divide by whatever's in front of the variable. So we're going to divide by -5 here. Whatever you do to one side, you must do to the other, leaving us with r equals 3. If this was a question on your homework, all you'd do is type in 3. Okay, moving on. All right, you know what? I'm going to make this our last example. We're not going to do 6, we're just going to do 5. And this one is it looks more complicated, but you just have to remember to take it step by step, okay? So we're going to solve for x. And I know this looks like a lot because we have 2 sets of parentheses, but it's okay. All that means is we're just going to have to distribute twice. We're going to distribute this -4 into this parentheses, and this -4 into this parentheses. Now, they're not always going to be the same. They could be different. Let me see, the other example you were going to do, see, they were different. One's a 3 you distribute, one's a 5. But it's the same concept. So let's go ahead and do our multiplication here. So we have -4 times 1. That leaves us with -4. We have -4 times -5x. Negative times a negative makes a positive. So plus 20x. -4 times 8 is -32. I'm kind of second guessing myself. Yeah, I'm right. All right, -4 times 5x gives us -20x equals -36. Oh, I'm so glad we're doing this one. All right, let's combine like terms. So that gives us, let's see, we have a -4 and a -32. That leaves us what? With -36. And we have a positive 20x and a -20x. Uh-oh. That means they go away. They cancel each other out, leaving us with -36 equals -36. And you're like, what do we do with that? Well, anytime you have it to where it's actually equals right here, that means all real solutions. Any number works. So you'd say all real numbers. Now, if by chance this happened and these were not equal, you would say no solution. All right? So do not forget to do your homework. Everything is due by Friday at 1 o'clock. So thank you, and hope you have a wonderful day.